Good morning, boys and girls. Mr. Giomini. I'm going to show you a couple examples from lesson 3.6, solving equations with integers. We did some of these in class today, or some similar to this, I should say. You also see some similar to this on your evening practice tonight from lesson 3.6, practice C. So if you need a little refresher, here we go. Taking a look, I'm not going to do all of them, just do a couple of them. Let's focus in on number 16 here. So number 16, I'm just going to rewrite it down here. I always like to rewrite these. Instead of trying to do it in my head, because again, my goal is to get these right. I'm going to take my time, do the work that's asked of me so that I can make sure I get all the points. So if I take a look, it says negative 63 equals negative 9 times s. Now the first thing I'm saying to myself is I know that I have to multiply negative 9 times a positive number. Because when I'm multiplying and dividing integers, when the signs are opposite, the answer will be negative. So this is already a negative, so that means this has to be a positive. Now also, I know going back from chapter 2, when I'm trying to solve an equation, I'm trying to figure out how much one of these variables is worth. I don't care what negative 9 is worth. I want to know what just 1s is worth. So I need to evaluate for 1s. So to do that, I need to do the inverse of whatever this operation is. So right now it's saying, hey, multiply negative 9 times something to get negative 63. Well, I know the inverse of multiplication is division. And whatever I do to one side of this equation, I must do to the other. I want to keep this balanced. So I'm going to divide both sides by negative 9. Okay, a negative divided by a negative, that leaves me a positive s, which is what I want. I just want 1s. Try to make my s's not look like 5. So I have negative 63 divided by negative 9. And I'm thinking to myself, what times 9 gives me 63? That would be a positive 7, because we have a negative divided by a negative, it gives me a positive. Now the step that some of you forgot to do on your post-test from chapter 2 is to then check this. So once I've solved and evaluated for 1s, I'm going to check it by substituting it back into the original equation. And now I know the value of s is now 7. So I put it back in, substitute it back in. This still equals negative 63. Negative 9 times 7 gives me negative 63. I see that both sides of the equation are negative 63, so that would be check. I know that my answer is correct because in the equation, I want both sides of the equation to be equal to each other. All right, let's take a look at another one. And one that I anticipate some problems on would be something like a 17. And so let's take a look at 17. We have 14 plus m is equal to negative 10. Okay. Now, in this situation, I am not really evaluating for an s. I'm trying to isolate this letter m. I want this m by itself. So the previous one, I had that coefficient of negative 9. This one, there's no coefficient with the m, so I'm going to isolate this m to get it by itself. Well, I don't want to bring the 10 over here because that'll leave me with nothing on this side of the equation. So what I need to do is get rid of this 14. Well, this is a positive 14 because there's no sign in front denoting that it's negative. So it's assumed that it isn't positive. So to get rid of that positive 14, I'm going to subtract. So what we're left with is 14 minus 14 is 0, which is exactly what I want. That'll isolate that m by itself. Now I need to subtract 14 from here. Now I'm going to rewrite this horizontally. I don't like to do it vertically, especially with integers. So I'm going to go negative 10 minus 14. If I am envisioning this on a number line, I am right now at negative 10. I have just become 14 smaller, so I will move to the left 14 spots. So because of that, I know I'm going to take negative 10, put that addition sign in here, and put negative 14. I know Ms. Banjoff loves to talk about money with these. You borrowed $10 from me, now you just borrowed another $14 from me. So now you actually owe me a combination of those two amounts. So combination, think about addition. So I just simply add. A negative plus a negative will give me a negative. 10 plus 14 gives me negative 24. So my answer would be negative 24. Now again, that is my solution. What I should do to check, again, if I want to make sure in every single point possible on the quiz, I want to substitute, or on the post-test, substitute in the original equation and see if it makes the equation true. So I have 14 plus, I'm going to put this in parentheses to show the separation of the negative sign of the plus, the operation, is equal to negative 10. Okay, this side, the right side of the equation, I do nothing with. It just stays the same, negative 10. Okay, I have 14 plus negative 24. Signs are opposite, so instead of adding, what I'll do is subtract. Think about it this way. It's 14 degrees out. It just dropped 24. It would make no sense then for the answer to be 38. So it's 14 degrees out. It just dropped 24. So again, if you want to envision this on a number line, I'm at 14. It just dropped 24, so I'm moving 24 units to the left. If I move 14 units left, I'm at 0. Sorry, yes, and if I need another 10, so let's take a look. So 14 minus 24, again, that would give me negative 10. Both sides of this equation equal negative 10. That is a check. That's what I want. Both sides are equal. So there is my final answer. Yes, indeed, m does equal negative 24. This is the check to prove that m does equal negative 24. Let's take a look at another one. And I'm going to take a look at number 21. Okay. So I have negative 6 is equal to 21 minus n. Okay. Again, I like this problem. It's obviously it's some type of operation we're subtracting. Well, I need to first isolate this n. So I need to get rid of the 21. Now to get rid of the 21, what am I going to do? Well, this is a positive 21 because there's no sign in front to denote it as being negative. So that means it's positive. So to get rid of it, I will subtract it from both sides. Now, I left with on this side a little tricky. I have a negative n on this side because it's subtracting that n, so I'm taking away, so it's negative, equals. Now, I'm going to write this horizontally. It makes more sense to me. Negative 6 minus 21. If you want to think about it, you borrowed $6. Now you borrowed another 21, so you definitely owe me a lot of money. So I would write this, say, hey, this is really negative 6 plus the 21 I borrowed later on. So both are negative. If you want to visualize this, I'm at negative 6 on the number line. It just dropped another 21 degrees. So I am now at negative 27. Now, something that looks odd about this equation, or this solution, is I have a negative variable. But I don't want to figure out a negative variable. I want to know what the variable is for positive. We're not solving for a negative variable. And let's take a look real quick to see what this would look like if I substitute it back in. So now I have negative 6 is equal to 21 minus, now we say this is a negative 27, right? So negative 27. So if I say this, I go negative 6 equals, let's see, now this changes to a positive. So I have 21 plus 27. Well, that gives me something like, what, 48, which makes no sense at all. So what happens, because that doesn't check, what happens when I have a negative variable here? How can I get rid of a negative? Well, I'm going to multiply it by another negative. So if I multiply this by another negative, I have negative times negative n. Or I can multiply it by negative 1 if I want to visualize that. Think about it more. I'm really multiplying by negative 1. So that gives me a negative times a negative gives me a positive, so that gives me 1. A negative times a negative gives me a positive 27. So n would equal 27. Now, let's substitute that back into the original equation. Negative 6 equals 21 minus n is now equal to 27. Oh, this makes so much more sense now. I have that negative 6 is equal to, okay, now we talked about this. When I am subtracting numbers, subtracting integers, when that second number is larger than the first, and the first is positive, we know our answer is going to be negative. So 21 minus 27. Well, if I'm at 21 and I move 27 to the left, on a number line, I'd be at negative 6. Or I can write this and say, hey, I know it's going to be negative. Let's just put let's put the larger number 27 on top, minus 21. That gives me 6. And that checks. All right, hope that helps you out. In your preparation for the assessment tomorrow, and then also on the post-test that'll be coming soon. Take care. Have a great day. Bye-bye.